Hi, my name is Arushi Jain. I'm a system application engineer with the radar sensors team at Infineon. Today, I will introduce you to the Sense2GoL Pulse development kit. So let's begin. The box comes with a USB cable, a corner reflector, and also the combination of both the boards. The Sense2GoL Pulse development kit is a combination of a 24 LTR11 shield and a baseboard which has the microcontroller on it. It is designed for a low power application, for motion detection, and also for approaching departing information of a single target. Before you begin, please make sure that the P8 and P9 headers are connected this way for the radar GUI settings. Once you have checked your jumper settings, connect your USB cable into the default port. And now you're good to go. The first step is to download the toolbox from infineon.com/toolbox. Once you have the Infineon toolbox, you will see nothing is installed at the moment. Go to Manage Tools and look for Sense2GoL Pulse and install it. Also go and look for Radar GUI, install the latest version as well. Now you will see three tabs in your Infineon toolbox: Radar GUI, Sense2GoL Pulse Kit, and the XMC Flasher. Open your Sense2GoL Pulse Kit. You will see a short description of the board along with some summary of features. It also has a getting started guide for your reference. When you click on this download button, you will have access to all the files that you need. In this folder, you will find everything that you need. We have documentation, which are all the application notes, also some user guides. In the firmware software, we have the binary and also the entire dev project. The communication library also has the C interface and also the MATLAB. In the hardware folder, we have the Altium files, the schematics, and also all the production data for both the boards. Now that you have all the files that you need, we are ready to play with the Radar GUI. Once you open the Radar GUI, you will see this default view. On the left pane, you will see some system settings and also the DSP settings. For example, with the pulse width, it is the on time of the BGT. The longer the pulse width, the higher will be the power consumption. The sampling frequency is also configurable. The samples per frame are the samples collected in each frame. The skip count is a little bit special, which is an added feature for getting rid of the DC offset in the time domain data. The continuous mode can be selected to have the maximum possible frame rate. This will make sure that your samples are always equidistant. Changing the settings in the system will have a direct impact on the settings available in the DSP. The minimum and maximum speed will determine the speed range in which you want to detect the target. Motion sensitivity and direction sensitivity are two thresholds. The red line here in the frequency domain spectrum refers to the motion sensitivity. If a target is above this threshold, it will be detected as a motion. You can make it higher or lower to make the system more or less sensitive. The default button will always revert back to the default settings. The revert is like a cancel. The make persistent will write the settings to the board so that it can retain the settings even when it is disconnected from the Radar GUI. The save and load is for saving the setting file that you have generated here and also to be able to use it in future by loading the same file. As you see here on the right, we have a motion and a direction tracker. This will tell you a time-based indication of when the movement was detected. The direction tracker does the same, but also gives you the direction movement indication here. Depending on the settings that you choose, you will see this current consumption value change as well. The pulse configuration shows you what a frame would actually look like. And here you can see the calculated values from the algorithm. You also have the possibility to refer to the application notes just by clicking on this icon. The recording of the data also works for a pre-processing application. You can select to write the raw data into a text file and also decide whether you want to do it on a time-based setting or a number of frames-based setting. You can also play back the same data that was just recorded. If you accidentally close a window that you didn't want to close, you can always go back to reset perspective to get back to the default view. The board is designed for low-power applications, like smart lighting, being triggered based on a motion detection. It can also be used for an automated door openers based on approaching or departing movement. A new and rising application for radar is also security cameras being triggered based on movement. Privacy is always a concern in sanitary applications. Radar is also a very good solution there. So now you're all set. For more information, go to infineon.com/24 GHz. Thank you.